AI agents are a major step in automation, giving systems the ability to plan, take actions, call tools, and run multi-step workflows. They often appear intelligent. That's why agents are used for automation, research, coding, and multi-step reasoning. But AI agents are not magic. They are an orchestration layer built on top of an LLM, and every design decision introduces a trade-off. Agents are designed to operate with a high degree of autonomy, acting without constant human supervision. They decompose tasks into steps, decide what to do next, and correct themselves during execution. This is what gives agents autonomy. However, increased autonomy introduces goal drift. An agent might pivot towards an easier or unintended objective. As a result, it may repeat steps, enter loops, or make irreversible decisions. Autonomy increases capability, but reduces reliability. Also, agents do not generate a single response. They rely on multi-step reasoning, chaining together multiple thoughts and actions. This process is commonly implemented using chain of thought, following a pattern such as plan, act, observe, and adjust. Multi-step reasoning enables agents to solve complex problems. However, each additional step increases the risk of error propagation. A small mistake in one step can be treated as ground truth for all subsequent steps. Multi-step reasoning adds depth, but introduces cascading failure. Agents extend their autonomy through tool use. They can call APIs, execute code, search the web, and interact with external systems. This significantly increases their capability. However, tool use introduces complexity. Function calling must follow strict JSON-formatted interfaces, which creates brittle coupling. Serialization and network I/O increase latency. Tool outputs may be misinterpreted by the model, and network failures can interrupt execution. Tool use increases capability, but also increases brittleness. Agents rely on memory to store previous steps, retrieve information, and maintain consistency across actions. This creates a sense of statefulness. However, memory is constrained by the context window, which is limited and expensive. In RAG systems, retrieving irrelevant or stale documents can poison the context. As a result, the agent may generate hallucinations with high confidence. So, memory provides continuity, but increases hallucination risk. Also, many agents generate an explicit plan before acting. This is often implemented using chain of thought or more advanced approaches such as tree of thought. Planning helps break large tasks into manageable steps. However, planning introduces overhead. Plans consume additional tokens, which increases cost. They also increase latency and expand the opportunity for drifting away from the original goal, meaning that planning provides structure, but increases cost and complexity. Another thing is that agents are designed to explore alternative actions when progress stales. This reflects the classic exploration versus exploitation trade-off. Exploration improves adaptability and flexibility. However, high exploration introduces risk. It can trigger unintended tool calls, waste compute, and produce actions beyond intended safety boundaries, meaning that exploration improves adaptability but reduces predictability. Some agents use reflection and self-correction to evaluate and revise their own outputs. This form of deep reasoning improves output quality. However, deep reasoning significantly increases cost. Token usage grows non-linearly. Execution time increases, and the surface area of errors expands. So, improved reasoning quality comes at a higher cost per task. Agents rely on stochastic sampling, controlled by parameters such as temperature. This stochasticity introduces creativity and variation in output. However, increased randomness reduces determinism. Outputs becomes harder to reproduce. Debugging becomes more difficult, and production reliability decreases. Creativity enables idea generation but reduces consistency. In summary, AI agents are not intelligent in a human sense. They are systems built from a controlled loop of orchestration, context management, and stochastic sampling. Each component increases capability and introduces risk. AI agents work by giving models the ability to act and accepting the trade-offs that comes with autonomous execution. Thanks for watching.